Hi Year 10s. So our first learning intention is drawing quadratics using a table of values. But before we start drawing them, what even are they? So the general form of a quadratic is something that looks like this. Y equals ax squared plus bx plus c. And a, b and c and c are just numbers. Alright, so for example, you could have y equals to 3x squared plus 2x plus 5. And in this case, a would be 3, b would be 2, and c would be 5. They're just the numbers in front of those different terms. You could have another one. You could have y equals 3x squared plus 2. Now, what would be a really good idea is to compare this equation here with this equation up here. And you might go, well, there's no bx term. There's no term which has the variable just x. And you're right. But it's still a quadratic, because the thing that makes a quadratic is the squared term. So as long as it's a squared term, it's still a quadratic, which means that y negative 4x squared is a quadratic, even though it doesn't have these two terms here. Now, if we look at the two shapes down here, that's what a quadratic looks like if you graph it. So it's very symmetrical. It can either be down or it can be up. So let's have a look at an example of that. Let's go on to drawing quadratics using a table of values. Well, we've got a table of values here, and we've got this example of drawing quadratics using a table of values where we've got y equals x squared plus 2, and we're going to draw it. We've got our axes down here. We've got a whole list of x values up the top here. So remember, when you've got an axis and you've got points on it, we label each point by saying what is their x coordinate and what is their y coordinate. Now what that means is, down here we should have a scale. So I'm going to put a scale, and the really important thing about a scale is that it's nice and even. So say we start at 0, we go out by 2 on both sides, we get 2 here, negative 2 there, 4 there, negative 4 there, 6 there, negative 6 there. It's very even. Now I'm going to do another scale up on my y-axis. And I'm just going to, for now, go, well, that point there on my y-axis, I'm going to go up by 5s. So that's going to be 5, that's going to be 10, and that is going to be 15. Okay, so then if I was saying what's the coordinate of that point, well, the x part of it is 4, because that's the value on the x-axis, and the y part of it is 10, because that's the value on the y-axis. Okay, so now with the example we've got here, we want to find all the y coordinates for those x coordinates that we've been given. So firstly, we've got y equals x squared plus 2. That's our general equation. Y equals x squared plus 2. And our first value for x is negative 6. So I'm going to find the y value when x is negative 6. Y is going to equal negative 6 squared plus 2. Put that in your calculator and you'll get negative 6 squared in your calculator. You'll get 36 plus 2 is 38. The really important thing to notice here is that I've put the negative 6 in brackets. And that's because the whole thing is squared. It's not just 6 squared, it's negative 6 all squared, which means that you end up with this positive number. So really important, if you've got a negative number here, you need to put it in the brackets and square the whole thing. Okay, so that's y value in there is 38. What about when x equals negative 4? Y is going to equal negative 4 squared plus 2, which is going to be 18. So because negative 4 squared is 16, plus 2 equals 18. And we can keep on filling it out like that. Let's do one more. So we're going to do y is going to equal, let's do what y is when the x value is -2. Y is going to equal -2 squared plus 2, which is 4 plus 2, which is just 6. And then if we did that for 0, we'd get 2, and then over this side we get 16, 6, 18, and 38. Now how could I fill that out so quickly? Well, I know from the last slide that the quadratic is, when I graph it, is symmetrical, which means it's the same on either side. So the value for 6 is going to be the same as the value for -6. The value for 4, the same for -4, and so on. It's going to be symmetrical. For this one example, where we've got 0 in the middle. You have to be careful with other ones. So you just, if you had a different one, you could just work these out the same way as we did down here. All right, now we're going to plot everything. So first, x scale. Is my x scale all right? Well, I'm going to go from -6 to 6. Perfect. What about my y scale? We went up in 5s before, but we've got to get all the way up to 38. So a scale of 5 is probably not going to work. What about if we went up in 10s? Let's do it evenly. So 10, 20, 30, and finally up here, let's go 40. Perfect. We have now fitted it all in. So let's plot our points. So -6, 38. Well, that's going to be -6 there. 38 is going to be pretty close up to 40. It's going to be about there. Let's plot 36, 38 at the same time. So a bit under 40 again, about there. Then -4, 18. So -4, a bit under 20, 18. And then 4, 18. And then -2, 6. So a bit over halfway to 6. And then 0 and 2 down there somewhere. Okay, so I can make those points a little bit clearer so that I know where to. I'm just going to make those a bit clearer. Now I'm going to join my dots. I have to be careful when joining dots, but here goes. To make it nice and smooth, and you don't want it to look like a V, you want it to look more like a curve. So let's make it look curvy, and if you, that's why we do grassy and pencil, because if you make a mistake, it's quite easy to just rejig it. And just to do that curve, and there we go. You want it to go through those points, so you might have to fiddle with it a little bit till it gets through those points. At the end of our graph, we always put arrowheads, like that, and we've drawn our quadratic. So there's an example of how to draw a quadratic using a table of values.